Hello class, and welcome to section 10.7, which is all about similar triangles. By the end of today's lesson, you will be able to identify similar triangles and use that idea to find missing sides. So similar triangles are the same shape, but they do not necessarily have the same size. So for example, here we've got two right triangles. Triangle ABC is bigger than triangle PNM, but they are the same shape. When we are writing similarity statements, if you are asked to do that, you need to make sure that you are lining up the correct vertices. So we would say triangle ABC is similar. That little curve there means similar to triangle PNM. A matches up with P, B matches up with N, C matches up with M. So you're looking for those vertices that are in the same spot on the triangle. So a couple things to note. If two triangles are similar, so again, same shape, probably different size, that means their corresponding angles are congruent. So if I back up here, that means angle A is the same size as angle P. Angle B is the same size as angle M, and angle C is the same size as angle M. So those matching angles are the exact same sizes. The corresponding sides are proportional. So what that means is I can multiply or divide by the same value to get from side to side. So for example, if I said this big triangle had measurements of 6, 8, and 10, I could say, for example, that the smaller triangle is half that size and say 3, 4, and 5. What that means is if you set up a ratio, so for example 10 over 5, that ratio should stay the same for all of the other values, which in this case it does, because they are all equal to 2. It does not matter if it is big triangle over small triangle or small triangle over big triangle, as long as you are consistent as you set up those ratios. So again, angles congruent, sides are proportional. So first thing we're going to do is decide if they are similar. One thing we need to remember is that triangles add up to 180 degrees. So I'm going to look at triangle STQ first. That tells me I've got angle measurements of 57 and 57. 57 and 57 give me an answer of 114. So I need to take, and I need to do 180 minus 114. And that's going to give me an answer of 66. When I look at this other triangle, I've got a measurement of 66, so I'm going to do 180 minus 66, which gives me an answer of 114. These two marks means that those angles are the same side, so 114 divided by 2 gives me 57. So because all three angle measurements are the same for both triangles, you would say yes, triangle X, Y, Z is similar to triangle S, T, Q. So again, matching up those vertices. The second one, that's using the idea of proportional. So I need to look at the two triangles. I've got this smaller one on the inside and the bigger one all the way around the outside. So I need to check if I've got proportional sides. I'm going to do small over big. So I'm going to say 3 over 9. That reduces to 1/3. I'm then going to check the top pieces, which are 4 over 12. That also reduces to 1/3. And then I'm going to check the hypotenuses, which is 5 over 15. That also reduces to 1/3. So again, these triangles, yes, are similar. And in this case, I'm going to say triangle WXY is similar to triangle VXZ. So again, if it is asking you for similarity, if it is yes, you need to write that similarity statement. If it is no, you need to explain why. Either the angles don't match or the sides are not proportional. We can then use these ideas of proportional sides to help us find missing measurements. We are also going to utilize our Pythagorean theorem during this process. So, right now we've got our inner triangle, which is smaller, and our outer triangle, which is bigger. I know the up and down of the inner is 5, and the base is 7. Base of the bigger one is 11, so I can use that to find the height. So I'm going to go ahead and set up a proportion and say that 5 over x is equal to 7 over 11. Remember, in order to solve proportions, we can cross multiply. So I've got 7 times x is equal to 11 times 5, which is 55. Solving that problem by dividing by 7, I get an answer of x is equal to 7.86. So this height value is 7.86. That's for x. We are still missing y and z. Y we are going to find using the Pythagorean theorem. It's a right triangle. So I've got 5 squared plus 7 squared is equal to y squared. 5 squared is 25. 7 squared is 49. So that still equals y squared. Adding those together, I have 74 is equal to y squared. In order to solve that, I'm going to take the square root and get a value of y is equal to 8.60 after I round. So that means the hypotenuse of this smaller triangle is 8.60. I'm then going to use that idea to find the hypotenuse of the longer triangle. So again, we're going to use proportions since we know these are similar triangles. So I'm going to take, and I'm going to say my value of 8.60, which is the hypotenuse of the short one, over z, which is the hypotenuse of the long one, is equal to 7 over 11. I also could have set that equal to 5 over 7.86, but to avoid some decimals, I'm going to use 7 and 11. Again, we can cross multiply to solve, so I get 7z is equal to 94.63. Solving that problem, dividing by 7 on both sides, I get a value of z is equal to 13.51. So again, the key thing here is to figure out where those similar sides are lying and then set up fractions or ratios to solve for those values. Go ahead and try this one on your own. First, to solve for a, I've got a over 12.5 is equal to 7 over 5. Notice, this time, instead of going across the triangles, I set up the ratios within the triangles. That is okay as long as you have the matching pieces corresponding. A matched up with 7, 12.5 matched up with 5. I also could have set this up to say a over 7 is equal to 12.5 over 5. Notice how it doesn't matter how I set this problem up, I still get that same value when cross multiplying. So the setup, as long as the pieces correspond, it does not matter either way which you set it up. So A is 17.5 and C is 20. Last thing we're going to talk about, a quick word problem. Tori is 5 feet 6 inches tall and her shadow is 2 feet 9 inches long. She is standing next to a flagpole. The length of the shadow of the flagpole is 12 feet long. How tall is the flagpole? Notice, first observation, we've got a couple of different measurements going on here. Since it is asking how tall the flagpole is, and it gives us the flagpole shadow in a 12-foot distance, we're going to want to turn everything into feet. So we know 6 inches is half a foot, so we're going to say Tori is 5.5 feet tall. And we know that 9 inches is 9 out of 12, or 3/4. So I've got 2.75 inches for her shadow. I'm then going to draw a quick picture to just show what this situation would look like. So we've got Tori and her shadow. So she's 5.5 feet tall, and her shadow is 2.75 feet. And then we've got our flagpole, which we know has a shadow that is 12 feet long. We're trying to figure out the height of that flag. So we can use the idea of a similar triangle because if I draw in a hypotenuse here, I have 2 right triangles. So those triangles are going to be similar. So now I can set that up and say the height of my flagpole over Tori's height is equal to the shadow of my flagpole over Tori's shadow. Again, cross multiplying to solve. We are going to end up with 2.75x is equal to 66 inches, 66 feet when we cross multiply. So now I need to, in order to solve the problem, divide by 2.75, which is going to give me a final answer of 24 feet. So I divided by 2.75 and got a final answer of 24 feet. If you have questions about this or anything else from the lesson, please let me know when you get to class.